Hey everyone, and welcome. Today we're going to roll up our sleeves and crack a proper GCSE maths question together, step by step. It might look a little tricky at first, but trust me, we're going to break it all down. Let's jump right in. So, here it is. This is the one we're going to solve today. Question 20, straight from a higher tier paper. I know, it might look a bit intimidating, but I promise, by the end of this, you'll have all the tools you need to tackle it with confidence. Think of it as a puzzle we get to solve together. So, what's our game plan? Simple. First, we'll look at the question itself. Then, we'll figure out what this turning point thing actually is. After that, we'll explore two totally different ways to find the answer. And finally, we'll wrap up by looking at the awesome new tools you've got. Let's do this. All right, first up, the GCSE question. Before we do any math, let's make sure we know exactly what the question is asking us to find. Okay, so the question gives us this equation for a curve, y equals 2x squared minus 12x plus 7, and our mission, find the coordinates of the turning point. The two big clues here are coordinates, so we need an x value and a y value, and that phrase, turning point. So that brings us to our next question. What on earth is a turning point? Before we start plugging in numbers, let's get a really clear picture of what we're actually looking for. In simple terms, it's that one special spot where the curve stops going up and starts going down, or stops going down and starts going up. You know, like the very top of a roller coaster hill or the very bottom of a valley. And at that exact moment, the slope, the gradient, is perfectly flat. It's 0. Now, our equation, with that x squared in it, describes a U-shaped curve, which is called a parabola. And as you can see, these parabolas always have a single lowest or highest point. Since the number in front of our x squared is a positive 2, our curve opens upwards, kind of like a smiley face. That means its turning point will be the very lowest point at the bottom of the U, and that's our target. Okay, time to find that point. We're going to start with method 1, which I like to call the scenic route. It's a fantastic technique called completing the square that actually rearranges the equation to reveal the answer hiding inside. So, we start with our equation. The very first thing we do is just focus on the parts that have an x in them. See that 2 in front of the x squared? We're going to pull that out from the first two terms. That leaves us with 2 times, well, x squared minus 6x, all in a bracket. The plus 7 just hangs out on the end for a minute. Now for the magic step. Look inside that bracket at x squared minus 6x. The trick is to take the number with the x, which is minus 6, and you just have it. That gives us minus 3. So we can write x minus 3 squared. But, and this is important, if you multiply that out, you get an extra plus 9 you don't want. So, to keep everything balanced, we have to subtract that 9 right away, inside the brackets. Then we just expand the outer bracket by multiplying everything by that 2 at the front. And all that's left is to tidy up. We do minus 18 plus 7, and we get our final beautiful form, y equals 2 times x minus 3 squared minus 11. Now, why is this so good? Because this form literally hands you the answer. The x-coordinate is whatever makes that bracket 0, which is 3, and the y-coordinate, it's just that number tacked on the end, minus 11. Okay, on to method 2. I call this the express route. If you've done a bit of calculus, this is a super fast and really powerful way to find any turning point. It's all about the gradient. We start with the same equation, of course, but this time, the first thing we do is differentiate. All that means is we're finding a new formula called dy over dx that will tell us the gradient of the curve at any point we choose. For 2x squared, you multiply the 2 by the power 2 to get 4 and drop the power by 1, giving us 4x. For minus 12x, that just becomes minus 12, and constants, like the plus 7, they just disappear. Now, here is the absolute key idea. Remember how we said the turning point is where the curve is momentarily flat? Well, a flat line has a gradient of 0. So we take our gradient formula, 4x minus 12, and we just set it equal to 0. Solving that simple equation, we get 4x equals 12, which means x equals 3. See how quick that was? But hold on, we're not done yet. That's only the x-coordinate. To get the full coordinates, we have to find its partner, the y value. So we take our x equals 3 and plug it back into the original equation. That gives us y equals 2 times 3 squared minus 12 times 3 plus 7. A bit of number crunching. 18 minus 36 plus 7 gives us y equals minus 11. Okay, let's take a breath. We have walked two completely different mathematical paths. We took the scenic route with completing the square and the express route with calculus. But did they lead us to the same place?
One method was all about changing the shape of the equation. The other was about finding where the slope was 0. And yet, incredibly, they both point to the exact same spot on the curve. That's the beauty of maths.
So, after all that, what's the big reveal? What is the answer that gets you all the marks? And there it is. The coordinates of the turning point are 3, -11. Both of our methods confirm it, which means we can be absolutely confident in our answer. That's the solution. Job done. So we've solved the problem, which is great, but the real win here is about the tools you've just seen. You didn't just find one answer. You've now got two powerful techniques in your mathematical toolkit. Let's put them side by side. Completing the square is brilliant for really seeing the structure of a quadratic. It literally rewrites the equation to show you the answer. Calculus, on the other hand, is just pure speed and power. That core idea of finding where the gradient is 0 is a game changer, and it works for all sorts of complicated curves, not just these ones. So the next time a question like this comes up, you've got a choice. Are you going to take the scenic route to really understand the structure, or are you going to take the express route to get straight to the point? There's no wrong answer. The best tool is always the one you understand and can use with confidence. So which path will you choose? Thanks for joining me.